Hello everyone, my name's Josh. People know me as JP from Primary Engineer. Welcome to this week's edition of If You're an Engineer, What Would You Do? Online interviews. Today we have Masoud Hakimi, who's from Anglia Ruskin University, and who just give us a wave there. We're very welcome to have him on board with us today, a new engineer who's going to talk us through his, a little bit story about himself and a particular topic about engineering. Without further ado, I will hand over to Masoud, who will do introductions.
Okay, my name is Masoud Hakimi. I'm a senior principal lecturer and practitioner at Anglia Ruskin University. And basically, I've been designing, developing product for many years in UK, and for both UK companies and international companies. So that's me.
And you do have a presentation for us, Masoud. So I will bring that up as well. So you can obviously share that presentation with everyone that's watching today. And just a quick info for everyone else. If you, while the presentation is going on, if you want to send us all the questions in, I can then go through with them at the end. Any questions are welcome to Masoud. And this is, again, the meaning of this meeting today is to get young children inspired to become engineering, to take the path of future engineering, and to get those entries sent in to us as soon as possible so we can see everyone's fantastic ideas. So without further ado, I will share my screen for you and you can talk through the presentation. I'll be a second. And if you let me know when it's up, Masoud, I can then...
Right.
Okay. Yeah.
Yeah, thank you.
Okay. Off you go.
Okay, well, as I said, welcome to my presentation. My name is Masoud Hakimi, and I basically, I'm an engineer, and engineering has got a big, wide definition. I mean, you can actually, especially in English language, you can call anybody virtually engineer. However, in different countries, engineers are classified the same as doctors and lawyers, very professional. And the engineering type today I'm going to talk about is that basically hardware engineering and software engineering, which relates to electronic engineering, wireless communication. These are all good fun. The stuff that you use every day. And then I'll go through it. So hang on a minute. Did you know this is, for example, electronic engineering and so on then. So I'll expand it and then basically most probably maybe expand into mechanical engineering a bit as well. But this is things. So what I'm going to talk about is Internet of Things. It's like you connect everything to everything, and it's good fun. So if you can go to the next page, please. So what it is that basically we've got this concept. We can actually, because of the telecommunication, the wireless communication, everything is actually expanded, the technology is moved, so we can actually now in a position to connect everything we can find to everything else. Like, for example, this meeting is online meeting. This is software engineering. You see, everybody, you guys, you're sitting on internet, watching your laptop screen. This is all engineering. This is basically, we are all connected together. So that's one of the things, like, for example, Internet of Things. But that's basically the communication bits and so on. So we can actually collect data, share data, and then use the information to improve things. For example, if you've got a football match, and like if England is playing, and suddenly there is a break, and everybody, there is a stats that shows that everybody runs into the kitchen and try to make a tea or cup of coffee. And then the increase of electricity really sharp, shoots up. And then there is a power surge and so on. Then. So everybody is got to be aware of it. Whenever England is playing, it's a big match, you've got a break. At the break time, the electricity needs to be basically sufficient. Otherwise, there's going to be a short of electricity and power cut and so on. So these are the information you can actually control and look and so on. So I'll explain to it a bit more as we go along. So if you go to the next one, please. So in here, for example, we can actually look at the stuff that any of the devices, as you can see over there, you recognize all of them. For example, there is a TV, we've got a TV there, we've got Hoover, we've got washing machine, you've got cooker, speakers, coffee machine, like basically microwave. These are all, you can actually, they've got basically electronics engineering, like for example, microwave. Microwave has got a computer in it because you can actually set the power, you can set the time, and then you decide how long you want to cook it, you want to defrost it, and so on. So it's all computer actually sitting there. So it's got a display, it's got a button. So this is all engineering. Like for example, fridge freezer has got computer in there to control the temperature, whether you want, what temperature you want to set it, and make sure everything is all right. So we can actually then control everything and then do it either by hardware, which is like components, mechanical, electronic components, or software, which we are doing it by basically programming language. So if it's just basically, then everything can be connected, then we can control things. So if you move on to the next page, please. Look at this one. For example, is we can actually have a smart city. Smart city that basically we can actually connect everything together through the internet and monitor it. Like for example, that started in 80s and 90s. I was working for a company called GEC. They were the biggest electronic manufacturing company in UK. And we were supplying the traffic lights worldwide, and especially to Hong Kong. And we managed to control the whole entire traffic of Hong Kong by the mainframe computer. So we could control every individual traffic lights to see how we could actually then control the flow of traffic in the city, because sometimes it's too busy, and then you've got to actually change the timing of the traffic lights. Sometimes you make it shorter, sometimes you make it longer. Otherwise, everybody gets stuck in traffic. So we could actually control the entire traffic of a city. Like for example, if you're in Oxford Street, all the traffic lights are networked together, they're connected together. You just, if you do about 80 miles an hour, you should pass all the green lights. And that's really good fun. So this is how we can do it. Like for example, if you go to a city like Cambridge or London or whatever, like for example, Cambridge, they've got a serious parking problem. And people that can't actually park because there is a shortage of spaces. So what we have is that we've put computers in the parking so they can actually count the number of cars going into the car park, count the number of cars coming out of it, and then we've got display across the city, which tells you how many spaces are available in each car park. So then we can actually, then people can decide, hang on a minute, I can't go to this car park because it's too many, there is no spaces, or I can go to that car park, always plenty of spaces. Now, even the smartest one, the latest one, not only when you go to the car park, the actually multi-story car park, it actually tells you which are there empty spaces rather than trying to find a place, empty space, so you can actually park in it. So this is how the technology is moving. It's all engineering. It's all hardware engineering, software engineering, networking, internet, and so on. So that's how we control things. Can you move on to the next one, please? And look at, for example, DHL. I mean, as an example, you can actually track it. So DHL is a service that provides everything, the same as Amazon. So they're really busy. They basically, you order something and then online, and within 24 hours, you get it. And nothing is actually handled manually. Everything is robot. You've got robots running around, collecting stuff, and then you can actually get this stuff there. You can track it. And then you can obviously, you've got all the vehicles, everything needs to be monitored, so you can actually service it and so on. So whenever, for example, you go online and trying to order food, a lot of companies, they use robots. The robots basically run around and do your shopping for you and put it in a package and send it home. So everything, as you can see, we've got sensors, it's called sensors. So we've got sensors and we've got the readers, and we can actually track everything and monitor everything. So if somebody posts something to you, you can always go online on internet and track it in real time to see where is it. Oh, hang on a minute, it's over there. And you can actually see, for example, with the parcel force, it actually gives you a map. You can actually have a map and you can actually see where the van is. And then depends where the van is or whatever, and then what time your delivery will be available and so on. So this is the technology information that you can actually have access to it all the time. So this is engineering again. So if you can move on to the next one, please. So look at this one. For example, you've got the house. You can recognize everything in the house. So I can, for example, I've just designed artificial intelligence. It's a board I've got, which is called MX30 Internet of Things, and I can control everything from it, with it. Say, for example, from China. I can actually call it from China and control things, heating, lighting, and so on. Like, for example, at the moment, I talk to it. If I say red light, it actually turns a red light on. If I say green light, it turns a green light on. If I say blue light, it turns a blue light. So if I talk to it, it actually responds to it. To me, actually does it. So everything in the house, you can actually then control it with Internet of Things. So if you're on holiday, for example, you can actually monitor, for example, if you've got a camera, with a security camera, you can monitor your house to see exactly what's going on. And obviously everything can be recorded and whatever. So that's the security things as well. And so on then. So for example, your television, you've got a smart television, and most probably a lot of you've got Netflix or Amazon Prime and so on there, or Disney and so on there. So they are all streaming film and the internet. So this is all software engineering, which is basically goes into the smart television, and that's hardware engineering. So like the actual television is got a computer in it. Look at the mobile phone. Mobile phone, how many of you guys got mobile phone? I think everybody's got a mobile phone. Okay, mobile phone is a computer, is electronic engineering. So it's got a computer in there, and then obviously it's got a display, and it's got receiver, transmitter, so you actually can talk to the GSM system. Depends whether you've got using Wi-Fi, you've got Bluetooth. So these are all electronic engineering, which is got software and hardware. So depends, you can go to different manufacturer and buy different mobile phone. Now, when the first mobile phone came out, for example, it used to be like a suitcase. So they were about a few £1,000s, and it was a suitcase, and it had a massive battery, and it will only last a few hours and so on. So you could actually run around with a suitcase and then open your suitcase and make a telephone call. Now they are very cheap, and they can actually fit into your pocket, and then they last minimum 8 hours, because that's like a shift work and so on. So this is all hardware software engineering, and it's really good fun and so on. Okay, so it makes life much easier and comfortable, and you can actually control and monitor things and so on. So if you move on to the next one, please. So look at this one, like I'm sure everybody's got smart watches. That is electronic engineering, telecommunication engineering, and then obviously the cases which goes in it is mechanical engineering. So you actually design this stuff, you put all your electronics, and then you need to actually put it into a case that it can actually be used and so on. So this is like, for example, you can actually look at it for your health care and fitness, running around, how much you walk, how much you can actually, how far you can run. So these are, then you can actually get it on your different phone. I think Apple has got smart watches, which is quite expensive and so on. Then, but as soon as they can talk to your mobile phone and then receive and send information, text messages, and so on. So these are all computer technology. They're what's called, we call them microprocessor, and we can control things in a wireless communication fashion. Next one, please. So when you actually look at these one, you can actually monitor, I mean, obviously for healthcare, these are important. You can actually monitor heart rate, calorie intake, sleep, track activities, and many, many other things and so on. And these are quite information. The information technology is basically so advanced, it's becoming smaller and smaller, and it's cheaper and cheaper. Now we've got, there was some engineer from Intel, I think it was in 70s or 60s, he predicted the number of ICs, electronics like transistor or components, will double up every 18 months. And now, for example, Intel computer, which is the quad microcontroller processor they're using, they managed to get over 20 billion components on a computer. So you get an IC, small IC, and it's got over 20 billion components on it. So this is how everything becomes smaller and cheaper and lighter. So we can actually save energy as well. That's the green energy for the green environment. This is how we are actually working. We make everything to use less power and last longer, and so on. So if we can move on to the next one, please. Look at this one. This is my favorite one. As I said, I've actually designed a board which is used both in universities and educational establishment in UK and China. My board actually used in a number of modules in various universities and so on. And this one is like, for example, have a look at this one. Wireless body area. So you can actually monitor things and send information wirelessly. So look at this, for example, nowadays with the pandemic is causing problem. For example, doctors can't actually see the patient because of they're worried they might catch COVID-19 and so on. So a lot of these ones you can actually have, if you have this sort of technology, you get it to the patient and then you monitor them remotely. So you attach them, the doctors, they don't even need to visit the patient anymore. They can actually sit there, look at the, for example, the blood pressure, look at the temperature, and various stuff on whatever. That's all sent through the internet, and the doctors can actually only go in during emergency if there is something seriously needs to be done. So a lot of stuff is done remotely, and as you can see, it will save time, it will save driving, traffics, and all of these ones that you can actually improve and so on. So that's part of Internet of Things, that you can actually connect everything and so on. For example, in this example, is using 3G and 4G technology. That's the mobile phone. Obviously, now we've gone to 5G, which is even faster. But also, we can actually use other technology as well, and so on. Okay, so that's another example of Internet of Things. So you can actually use it in all sorts of application. You can use it, for example, in gym. If you go to the gym, you're actually on exercise machine. When you put your hands on the, for example, handlebar, if you're actually running or something, it will automatically measure your heartbeat, your temperature. So this sort of thing, so you can actually see how fit you are, and so on. So this is basically all this stuff can be used in various stuff for monitoring, hospital monitoring equipment, personal use exercise equipment, and so on. Then. So as I say, everything is the prices are coming down, technology is improving, and everything is getting smaller and cheaper, and so on. Then. So we can actually use it. Can you move on to the next one, please? And look at this one. That's my favorite again, is car. If you look at the car, now the car you drive, majority of it is now electronics. It's got hardware electronics, software electronics, and obviously you've got mechanical engineering in it as well. So you've got hardware, software, mechanical engineering. Now look at everything in the car. For example, you've got sat nav. So you don't actually have to get lost anymore when you're driving around, confused. You use the GPS tracking system. It's got all sort of sensor. It's got what's called CAN bus. CAN bus is that like virtually everything is connected through a serial bus. So you can actually have connected, like for example, Wi-Fi, Bluetooth, and so on. Then cameras and all the other information and sensors in the car are actually connected together using the CAN bus, which is a sort of hardware communication. Now, if something, for example, goes wrong with your car, now this one automatically can collect the information, for example, call the AA automatically for you, or it can send the information to your local garage. So you can actually then, for example, automatically get your car booked in for a service and then go and have it serviced. Now, when it goes to the, for example, garage for a service, I don't think nowadays the mechanical engineer or the technicians or car mechanics are going to go and have a look at everything. What they do is that they get their laptop computer, they come in there and then open the bonnet, plug in their laptops, and read all the information from the actual engine management unit, because the car has got a very powerful computer in there. It's called engine management unit. So it actually reads all the information from the engine. And when it reads the information, it tells them exactly what they need to do, what it needs replacing, and what's the problem. So the actual car mechanics automatically can actually go and fix the problem. And normally I've noticed that the garage, even if there isn't any problem whatsoever, they charge between 50 or 100 pounds for just connecting their laptop to your engine, so to see what's going on. So that's the standard charge normally. Okay, so that's what it is and so on. So you can actually, everything is monitored, everything is controlled, and you can actually track it in real time and so on. So next one, please. Another one is, for example, space. You're sending basically rockets, jet engine manufacturers, and so on then, so you can actually have measure all sort of things with regard to the rockets, from the measure temperature, pressure, and other stuff and whatever, so you can actually to see what's going on. And then by measurement and this sort of thing, you've got enough data to actually improve the design, to improve what you're doing, how you're doing it, and how you can actually make it a bit more efficient and so on. So that's basically, you can actually use it for space technology and so on. So next one, please. So another one, for example, now is actually gone into farming. Farming is all the farmers. Now you've got virtually robots appearing left, right, center doing the farming jobs. Okay, so this is basically reducing the labor cost. Everything is automated. Now, more or less, you can actually go to, for example, shopping center and buy the latest out-of-season fruit, which in old days, you could only get it in the summertime. Now everything is actually produced most probably in a controlled environment that you can actually automate it and control everything in the farm. And I'm working on some of the projects, like for example, we can actually go in there and then one of the robots is that it can track up to about or recognize up to about over 50 different fruits and so on. Then. So it's like a face recognition system. So it looks at it, it decides what it is and whether it's ripe or not or whatever and what it needs to do. So we can actually then, for example, do weeding, do spraying, and all sort of things can be actually done automatically by remote control robot, looking at the humidity, temperature, soil moisture, and so on. So if you move on to the next one, please. Look at this one, for example, strawberry picking. Strawberry picking is it's very nice activity. If you are you've got a good weather, you want to go to the farm and have pick up some strawberry and then buy some ice cream and then enjoy your day and whatever. Now, obviously, it's a very time consuming. The farmers, they've got to actually make sure they've got enough people to collect all these strawberries at the right time because there is a limited window how long these strawberries are going to last and so on. So, but now it's all robots. The robots can run around and decide whether the strawberries are ripe or not, and then they collect them for you. So they pick them up, packetize them, and then obviously when it goes in there, automatically is packetized by robots, and then it's labeled with a sell-by date, the price, and the weight. So this is all fully automated one, which is another part of engineering. Can we move on to the next one, please? Okay, railway and passenger information system. This is interesting. I've been working with railway systems since 80s, and I don't know, most probably you guys are too young to remember the old railway system and whatever. Nowadays, we've got computer on the actual railway, and we can monitor everything from, say, for example, the number of passengers on board, how many seats are empty on the train, where are the, for example, the restaurant, which wagon is the restaurants, and you've got the Wi-Fi, internet, and everything on there. And then basically with the GPS and tracking stuff, we can actually monitor the entire movement of the train across the network. So at any time, we know exactly where the trains are. And as the trains are actually approaching the platform, if you've noticed, we've got a voice synthesizer, we actually make an automatic announcement. We say, for example, the next train approaching platform 2 is going to King's Cross. So that means basically the signal is actually automatically triggered and it actually announces the right one. And then it updates all the display on the platform. So all the information on the platforms are displayed and updated automatically because we control it. So everything on the train, we control it. And don't forget with the trains, there are thousands of trains. They've got trains everywhere. And it's impossible trying to actually maintain this train manually. So what we do, we just basically track all the information from the engine, what the problem is, and so on then, and we send it to the mainframe computer. And if there is any issue with any of the train, any of the wagons, it will automatically be pulled off the train, off the line, goes into the basically special area, and the maintenance people, they just go specifically to that train and fix the problem and put it back online again as well. So everything is done automatically without any, everybody worrying about. Just imagine trying to actually go and visually or check trains every day to see if they're okay or not. So the computer is doing it all for you. So these are all hardware electronics. software engineering, and also mechanical. So it's a combination of all of these one that basically forms part of engineering. Okay, if I go to the next one, please. And this is another one, car manufacturing. So, I mean, nowadays, everything is automated. I had one student working for BMW in Oxford, making minis. And he was telling me they can make mini, a whole complete mini within 24 hours from start to finish. So they've got the production line like that, and everything is automated through robots. So all they've got to do, make sure everything is actually supplied to the mobile robots, and they control it. They can actually change the program and so on then. So they can actually say, for example, produce a whole mini within 24 hours. And also we can, in engineering, we can actually predict what's the expectation or predict what's the lifetime of a component. So for example, a light bulb, we can predict, say, for example, this light bulb is going to work for 1,000 hours. And then after 1,000 hours, or when it gets plus or minus that one, it will stop working. So we can predict the component life and then adjust things accordingly. So we know exactly when and how long a component is going to last, and then when it needs replacing. Okay, so this is engineering for you. Next one, please. And now the fun bit is how to actually use engineering, computing, programmable logic analyzers, and so on then to actually design cakes and whatever you actually buy from supermarket. So this is a good fun. Have a look at this. What do you think?
Slow that up. Now I can see that some questions have come in, which is fantastic. So I will get to them after this video, which is loading up now. Full screen.
What's it doing? I can't see it in here on my screen. Is the video working or not?
Yes.
Okay. Well, I can't actually see it on this side. Is that okay?
Oh, is it now? Oh, is the video not working? I do apologise. I don't know why that was the case. I will try and get that working. Sorry about that. Just stop sharing.
Yeah, sure.
I will try and sort that out. Yeah, sorry about that. While I look at that as well, we will obviously look at some questions as well. So we've got a question here from St. Stephen's Primary. How far do you think internet technology will go?
Sorry, what was the question?
How far do you think internet technology will go?
Oh, how far is very interesting. Is sky's the limit? That's the answer, because it's moving so much technology. Like for example, I was in China. I was doing a live lecture in one of my lectures in Chinese university, and I managed to use my board with the Internet of Things and cloud computing, connect all the way through various networks and connect to my server in UK in live, and then monitoring things and so on. Then, so sky's the limit. So basically, everything is getting smaller and cheaper. So you should be able to just virtually monitor and automate things.
Fantastic, fantastic. I'm thinking of a question myself. So when you went back to the car, where you say that if you have a breakdown, it'll automatically ring AA or AC, for example. I've noticed recently on iPhone when if you have an accident when you're out, it automatically calls emergency services. Is that something that cars will be introducing at one point, where if you have an accident, it automatically rings through to?
Yeah, we've got say, for example, everything will be that. Like, for example, we are working on the projects is that basically is car collision detection system. That means if you're involved in an accident, not only the police will be called automatically, also the ambulances will be called automatically, and your location with the GPS will be actually announced to them as well. So everybody will arrive at the scene automatically.
Brilliant. And I've got a question here from, I'm going to say Clive Primary, I hope that's correct. What is your favourite type of internet technology?
What's the actual type of in the industry is actually expanding. Virtually, we've got, for example, anything that the industry can do, like construction industry, food manufacturing industry, also the manufacturing industry, car manufacturing. So a lot of application finding its way in different areas, like, for example, health monitoring. Health monitoring is a real expanding area. The other one is care homes. Care homes, we are putting Internet of Things, not only Internet of Things, we are putting artificial intelligence in care homes. So basically, we can monitor the behavior of a patient and be able to adjust the environment accordingly without the human intervention.
Brilliant. And now a bit also more of a personal question. So did you always want to be an engineer? How did you get into engineering? Was the engineering in your family, or, you know, how did it start off for yourself?
So how did I start it as an engineer?
Yeah. How did, you know, what's it inspired you?
I mean, it was basically, I always knew about engineering, but wasn't sure what it was. So then I said, I always used to pick up a screwdriver and trying to actually fiddle with things and so on. Then, so eventually when I went to university, then I said, at that time when I started, it was electronics. Nobody knew about electronics. That was in 80s. Like then, there was no computer, there was no internet. So we were basically working with things and then trying to find things and so on. Then. And then suddenly, for example, I was in the team that we managed to design and develop and invented the first push button telephone in this country. All right. If you remember, I mean, I don't know, these are the young guys or whatever. It used to be rotary phone. So you dial like 0, 1, and it just goes pulse, 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 pulse. So we were with GC, we were the first company to actually produce push button telephone for British Telecom. And one we were using at that time, Texas Instrument microcontroller, which was a computer. It was only 4 bits, and it didn't have any real-time interrupt, and there was a very limited memory, basically RAM and ROM, and we were basically limited, but we managed to do it, and it was fantastic. Now you've got, all sort of technology. There are 64 bits that are running into gigabytes of memories and so on, and you can do everything. But at that time, it was limited, but we actually designed the first push-button telephone for British Telecom in this country.
Brilliant. Now, what is the best route into electronic engineering? What qualifications do you need? And secondly as well, what has been your highlight of your career?
Well, basically, engineering is really good fun, especially, I mean, for me, I've always been designing and developing products, new ones. So all the time doing various stuff and whatever. So the best route is that there are various options you can actually do to do like apprentice program. You can actually do it, and then you can get some BTech maybe, and you just go to university. So you can actually get basically sponsored by various companies and trying to actually get into engineering. For example, like Southern Electricity, British, was a BP, Panasonic, Network Rail, Southern Network Rail, and whatever, because I used to run various programs and so on there for different universities and colleges. They used to always recruit people and then send them to university and colleges to train them specifically for their area.
Thank you. What security risk is there with external automation, and how will AI impact the Internet of Things as well?
And how the AI will act with internet. AI is brilliant. AI is that you can actually, I mean, as I say, you can totally predict. Say, for example, if you want to get a robot, make it a chef. And when you want to actually say, for example, you go to take away, you order food or whatever, say like, for example, I want this and this, or maybe this pizza with this sort of filling or whatever. The robots will actually just make it for you, okay? And then it's all prediction, that how you can actually predict, and whatever you want coffee, the robot will actually make the coffee for you, and so on. So a lot of stuff can actually be fully automated and controlled and so on then. So basically, obviously, what we do is that is what everybody says, oh, it's a job creation, you actually destroy jobs and whatever. Well, the other way is that also you look at it, you've got all this artificial intelligence, you've got all these robots, you've got all this technology, you need engineers to maintain it, to support it, to design it, and so on. So there is a highly skilled area that they can actually operate.
Brilliant. Thank you. When you mentioned the smart city earlier, obviously, I presume, you know, in the big cities of London, is that somewhere that's going to be spread across the UK or worldwide? You know, get more...
They do it. I mean, like in that was in Munich. There were about the whole entire city is controlled by a technology called LoRa. LoRa is called long-range communication. Long-range communication is a very low-powered device, wireless device, part of Internet of Things. You can network them, so virtually you can actually connect it to anything, to monitor as a sensor, and then send the information in. So that information gets filtered, and then you can actually then what's called smart city. So you can actually control, for example, the traffic. As the traffic, for example, gets heavy, you can actually divert them, you can control the lighting, you can control the heating systems and all sorts of things. So this is basically, there are already actually cities or is happening and so on there.
Fantastic. So what happens if anything goes wrong? Is the, you know, does it go wrong often, or is it, you know, easy fix?
Obviously, because they're all part of what's that gateway and network. So if something goes wrong, it won't bring the whole system down. It will be like a section of it, which then the engineers can go and service and maintain it and so on. I mean, obviously, if the main server goes down, then they've got to actually trying to bring it up or whatever. But normally, like, for example, in railway system, we have we've got hot standby. That means everything is duplicated. So we've got one is basically like, for example, computer running in real time, and it's in a hot standby, and then it actually monitors everything. And if it goes down, there is another one in parallel, automatically comes online and takes over. So we duplicate things.
Fantastic. So with all the people that are watching today, what is, you know, your advice to the schools who are watching today? You know, what's your advice to anyone who wants to become an engineer and they potentially face barriers in the future? What's your advice for them to stick to what they want to do, set the goals early, and continue with, you know, what they love and believe?
The advice is that basically, if you want something, you keep at it, all right, especially engineering. Look at the stuff like, for example, hardware, software. I mean, you're using mobile phone as an example. Everybody's got a mobile phone, but they never think about it, how it's actually made by engineer. It is all hardware engineering, is software engineering, all the technology behind it. I mean, like, for example, we are having a live video on here. This is all software engineering. Obviously, the backbone of it is the networking and so on. So I would say basically trying to do a bit of maths as well. It will be very interesting. Normally with engineering, it's not essential, but if you're basically trying to get good at maths, everything becomes much simpler. All right. But also practical activity. We do various practical activities and so on then. So basically get good A levels and BTech, good A levels, good BTech, apprentice program, and then we can get into engineering.
Fantastic. So the main message is keep focused, keep your mind on what you want, enjoy what you do, and you know.
Yeah.
Fantastic. Well, like I say, Masoud, you know, you've been absolutely fantastic today. So I do appreciate you taking your time to show us a fantastic and interesting presentation, asking all the questions that came in. And I'd like to thank all schools that took part for their time as well to listen to us today. And just a gentle reminder as well to the teachers, I will be in contact soon to talk about the project if you need any further assistance. The deadline is the 23rd of March. So make sure, you know, to get the done in school, use this interview inspiration to get those minds working, those designs flowing, send them in. We can't wait to see what they are. So next week we have another interview, which is at 1:30. So please stay tuned to see that. Dropping emails. But for now, I will say goodbye and thank you for joining.
Great. Thank you. All right. Bye. Bye.